So the last thing we want to do after running our regression is check our residuals for assumption violations. So first what we're going to have to do is compute the residuals, and then we can check them. In Stata, we have to do that after we run the regression. So let's pull up our do file here. And we've got all this. So all this code, you know, the word residuals, the word predicted here, those are the names of the new variables we're creating. So I'm going to go ahead and run these up to the histogram. Actually, I'll run to the summarize so that we can just kind of go straight through. All right, so let's split this. Oops, that's the zoom bar. Split this and take a look. All right, so we got our residuals predicted. We got our residuals added to the data file here. So if you go down over here, you'll see we have two new variables, residuals and predicted. So residuals are the error term, and predicted is the actual predicted value from the regression. All right, so we want to look at our residual histogram, skewness, and kurtosis. So the very same thing that we did with our descriptives up here, we're going to do with our histograms. So we literally just summarize our residuals. So we want the mean of the residuals to be 0. You can see that's pretty close to 0 right there. We want to look at our skewness and kurtosis. So we want our skewness to be around 0 and kurtosis to be around 3 in Stata. So that looks good. Once we look at our histogram, we can see those very same things. Looks pretty normal here, but in our histogram, we can also see whether there's outliers. And we do see that there's a slight outlier over here, very high residual value. So that's something we want to keep an eye out for. Not necessarily a red flag right now, but just something to kind of keep in mind. So next, we want to get our scatter plot of our residuals versus our predicted values. All right, now we want our scattered plot to be like nice and randomly spread out. We don't really have that, but what you'll remember is that we had this pattern where we had a ceiling effect with a lot of kids scoring 5 on interest. And so this is what you're seeing here. This is kind of, you can see that the scatter plot of the independent and dependent variable just sort of tilted a little bit, and you can see where that's coming from. All right, so we're checking our linearity assumption first. Is there a distinct curve? No, not so much. So this is still linear. Are the dots evenly spread across the entire range, or is there funneling? We have that same issue that we noted with the equal variance before, but we're not seeing a distinct funneling. So we're kind of still dealing with the same issues that we had at the very beginning, which are not concerning. And then we want to check the independence assumption. Is there anything that suggests the observations are related to each other? Not in this scatter plot. Now, another thing you want to do is run your scatter plot with your run your residuals with your independent variables. So in this case, we need to run this against belonging, which was our independent variable. So again, here we're checking that equal variance assumption. We don't necessarily see any, we don't see any funneling in this scatter plot, and we're checking the independence, and we don't see anything to suggest that the observations are related to each other. Once again, this isn't the perfect scatter plot because it's not all even, randomly spread out. But again, that's because we have a lot of people grouped sort of in one area of school belonging, and a couple of outliers hanging out over there. And then we want to look at our residuals versus some potential independent variables. So we could think, let's look at our data file and see what else might be predicting interest in school that we haven't included in our data set, right? So we look at our variables, you might think that something like how much a teacher supports you predicts your interest in school. So what we'll do is we'll run teacher support against our residuals to see if there's a distinct pattern. All right, so what we're looking for is there would be like a strong positive relationship between teacher support and our residuals, and we don't really see that. This is pretty randomly spread out. We can add a fit line to this to see if that fit line might show a more distinct, like more clearly show a linear relationship. So with our fit line, residuals, teacher support. With our fit line, it's going to look like that. And you can see there's a slight positive relationship between teacher support and our residuals. We can run the regression with teacher support to see if that changes anything. But right now, I'm not seeing a strong need to do that. Next, we want to look at our normal probability plot to see how closely the dots are falling all along our line. Because our residuals, the normality assumption is that the residuals are normally distributed. So this is our PP plot, and as you can see, it looks pretty perfect. So Stata is giving us the line here of where the dots should be, and as you can see, the dots are pretty closely clustered along that line. So that's great. This is a really beautiful plot. So our normality assumption is being met there. And last, we're going to check our independence assumption by looking for VIFs over 10. So both belonging and gender have a VIF around 1. So that is definitely within our range. So that looks good. All right, so now let's take a look at these things in SPSS. So with SPSS, when we run the regression, we already get some of these plots, and then the other ones we're going to have to check on our own. So let me go ahead and switch over to SPSS output, and we'll go back up. So now you can see in this syntax, so this is where we're actually saving our residuals and our predicted values. And I just named them predicted and residuals again. All right, so here we are. We want to check our normality assumption with the residual histogram. So here you can see that same histogram looks really nice, got a slight outlier over there. Our mean is practically 0. We don't get skew to synchretosis here, but we can run our frequencies on the residual, which is going to be saved down here, and get our skew to synchretosis. And there you can see it's very low, so that's nice. Back to our charts here. All right, so we're looking at the histogram, looks good. Next, we want to get a scatter plot of our residuals versus our predicted values. So that's going to be down here. So here's our residuals and our predicted values. And again, you can see that same pattern that we saw in Stata. We want to get our residuals versus our independent variables. So here is where we're going to have to use our chart builder again. This is just a scatter plot. So we choose our scatter plot. Choose our scatter plot. There we go. And our independent variable was belonging. And there's our residual variable down there. And there, that looks pretty good. We can also, I don't think I did this before, we can also run a residual by a categorical variable. It's not going to be quite as interesting just due to the nature of the categorical variables. But if you want to check the equal variance assumption, and again, I have to change this back to a categorical variable. You want to check the equal variance assumption, and a box plot would be a good way to do that with your categorical variable. So you can see these residuals are pretty evenly spread out based on gender here. There's that one outlier you can kind of see, but what you can tell here is that, remember how we saw our outlier in our residual scatter plot over here? You can kind of see who that outlier is coming from, and with that box plot here, that the outlier is coming from that one boy and this one girl over here. So it doesn't seem necessarily to be associated with gender, but these are the two people who are causing some slight issues with our residuals here. So if we wanted to look at those cases, we could take a look and see what's going on with them. But like I said, they're pretty close to the range. They're not huge outliers, so we're not too worried about them. All right, then we want to get our residuals by our potential independent variables. So that's going to, again, be just a normal scatter plot with that residuals, that variable that we calculated, and we would see that. To get our normal probability plot, that's included within the regression command. Right here, it's called the PP plot. And as you can see again, that is a really nice plot. And then our VIF, we're going to have to go back up to our regression output. And it's going to be over here, the collinearity statistics. So each line is going to be included with our regression. And here's our VIF of 1 for gender and belonging. And again, that is way under 10, so we are good. And so now we have checked all of our regression assumptions, and we are ready to write this up.